So I'm Michael Kricke, I'm application engineer with Maxim, and today I would like to show you our latest industrial power supply devices. We have a demonstration board here showing our small industrial power supply device, the MAX 17552, which is capable of 100 milliamp output current, and we have a couple of others here going up to the MAX 17504, which is capable of 3.5 amp on the output. And the nice things of all these devices is they have a synchronous rectifier with a high side and a low side FET for good efficiency, and they are all the way up capable of a 60 volt input voltage range. And the idea behind all these DC-DCs is to have nice solutions for the industrial space. And I would like to show you the MAX 17552, for example, which is our device with 60 volt input voltage range, 0.8 volt up to 90% of the input voltage range is the programmable output voltage, and the load current is maximum 100 milliamp. And consider the case you only have a very light load on the output. Let's call it 10%, which equals something like 10 milliampere load on the output. If I run this device in plain PWM mode and make it run, this will give us, from an input voltage range of something like 24 volt, we have an output of 5 volt, we load it with 10 milliamps, and the efficiency ends up with something like 75%. Not too bad, you might think, for such a small DC-DC converter in the industrial space, but we have one nice feature on this device, because, for example, you can run it not in PWM mode, but in pulse frequency mode, which saves a lot of quiescent current on the device and therefore improves the efficiency. If I change from PWM to PFM and run this thing again, watch the efficiency pointer. It goes up approximately 12% or so, jumping up to 86% of efficiency just by saving a lot of quiescent current on the DC-DC converter. Now it runs not in the plain PWM mode, but in pulse frequency mode, which is a sequence of pulses, and each time the output voltage needs to be regulated, more or less pulses are being led to the output, also known as pulse skipping mode, or PFM, how we call it, pulse frequency modulation. So this was the idea on our smallest DC-DC converter. Maybe let's go to the MAX 17504, just to demonstrate another device from this series on this demonstration board. The MAX 17504 is capable of a load current of 3.5 amp, and let's run this in standard PWM mode, load it with 100% and run it. And you will see that, first of all, the efficiency is close to 90%, although this device gives you 5 volt output at something like 3.5 amp of load current, which means this is something like 70 watts into the output. And if you touch the resistors here, you will figure out that they already start to get warm when I run this device. So this was the demo on the DC-DC converters. And in the end of my little speech here, I would like to mention also that we have not only the DC-DC converters as standard micro ICs, but also as modules. And here, with these so-called Himalaya modules, we, for example, in the MAX M17503, we take the MAX 17503 and marry it with a little inductor in a small package in order to give you a easy turn solution where you only have to add an input and output capacitor and maybe a resistor divider in order to adjust the output voltage. So this was my little presentation on Maxim's 60 volt industrial power supplies. Thanks for your attention.